All right, let's jump right into this explainer and settle a heavyweight matchup that impacts basically anyone operating heavy machinery. Today, we're looking at the fundamental, foundational differences between bias and radial tires. If you manage a fleet, operate heavy equipment, or handle procurement, this is absolutely crucial to your bottom line and your daily operations. You know, we've got to bust a major myth right out of the gate. Is the real difference between these tires just the external rubber pattern, like the part you actually see gripping the dirt? A lot of people assume you just pick a tread pattern that looks aggressive and call it a day. But actually, scratch that, it couldn't be further from the truth. The reality, the real magic, the stuff that actually dictates the physical characteristics, the sidewall strength, and how long that tire survives in the field, it's all completely hidden inside. It's the ply and casing construction. It is all about how the internal cords and cables are arranged. That architecture is what truly matters, and that's exactly what we're going to unpack today. First up in our head-to-head match is the bias tire, or you might hear it called a cross-ply tire. Picture cutting one of these open. You'd see multiple layers of nylon or polyester cords. And here's the kicker. They're woven diagonally. They crisscross each other, wrapping around the entire tire body from the tread all the way down to the bead at angles of roughly 30 to 40 degrees. Kind of like a tightly woven basket. Now, over in the opposite corner, we have the radial tire. Totally different ballgame here. Instead of all those diagonally woven layers, the radial relies on a single ultra-tough layer of steel cords. And rather than crossing diagonally, these steel cords run straight across the tire body, perpendicularly from bead to bead at a strict 90-degree angle. When you look at a cross-section of these two, the contrast is wild. You can literally see that woven 30 to 40-degree crisscross web on the bias side. But on the radial, it's just straight, perpendicular 90-degree steel cords with those rigid steel belts layered right beneath the tread. And hey, this isn't just a manufacturing quirk. This layout dictates exactly how your machine is going to perform on the dirt. So how does this actually translate into mechanical properties? Well, because of its wrapped, woven structure, the entire bias tire operates and flexes as one single, rigid unit. When the tread hits a rock and flexes, the sidewall feels it and flexes right along with it. The radial, however, thanks to those steel belts under the tread, allows its stiff tread area and its flexible sidewalls to act completely independently of each other. They're doing their own thing. This brings us to sidewall stiffness, which is a massive factor for durability and operator comfort. That rigid nature of the bias tire means its sidewall is incredibly stiff and robust. It's practically armor against lateral cuts and heavy sidewall impacts. On the flip side, the radial sidewall is highly flexible. Because it moves independently of the tread, it acts like a giant shock absorber, giving the operator a significantly smoother ride over rough terrain. Here's a quick pro tip to spot the difference in the wild. If you look closely at an unladen bias tire just sitting there, you'll actually see the center of the tread kind of crowning or bulging outward slightly. It isn't perfectly flat. That is a complete contrast to the radial tire, which, thanks to those stiff steel belts, maintains a perfectly flat contact patch, even with absolutely zero weight on it. And why does that matter when you actually load up a machine? Well, when you drop tons of weight on a bias tire, that crowned tread distorts in cups against the earth, which ultimately causes uneven wear along the shoulders or the center. The radial tire, because it starts flat and its sidewalls just flex out of the way, the tread remains perfectly flat under load. You're getting maximum uniform contact with the ground 100% of the time. Now, all this structural flexing directly impacts operating heat, which is, without a doubt, the absolute mortal enemy of tire longevity. Bias tires run hot. Why? Because as that single rigid unit flexes, all those crisscross nylon layers are literally rubbing against each other, creating intense internal friction. The radial tire, though, runs much cooler. Not only is there less internal friction to begin with, but that steel belt structure acts like a giant heat sink, rapidly conducting and dissipating whatever heat is generated. This difference in heat and footprint, it dramatically translates to tread wear life. Because there's less shuffling, less ground scrubbing, and less heat, radial tires absolutely dominate here. We are talking 2 to 3 times longer life than their equivalent bias counterparts. Think about that for a second. That is a massive reduction in how often you're pulling machines into the shop for fresh rubber. Of course, we've got to look at the financial bottom line. Bias tires are definitely a very cost-effective initial capital outlay. They're cheaper up front. However, because of their tire distortion and high rolling resistance, your fuel efficiency takes a hit. Radials are going to cost you more initially, for sure.
but they have lower rolling resistance. That means superior fuel savings, lower fuel consumption, and a seriously strong long-term return on investment.
So that brings us to field selection, where each casing dominates.
Now that we really understand the anatomy, let's bring this straight to the job site. You absolutely want to run bias ply tires if you're operating in highly hazardous environments. If your machines are navigating demolition sites, scrap yards, recycling facilities, places where hitting a piece of rebar or sharp debris is a daily reality, the risk of a sidewall cut is exceptionally high. You need that stiff, robust, cut-resistant sidewall. You also want bias tires if you need high static stability. Think of loaders doing stationary pivot turns under full load, or backhoes where you just can't afford the machines swaying back and forth while working. On the other hand, look at the conditions for radial tires. You should definitely equip your fleet with radials if you're doing long-distance, continuous hauling where heat dissipation is absolutely critical. If you've got rigid or articulated dump trucks traveling at higher speeds over long-cycle routes, radials will survive that heat. Plus, if your ultimate operational goal across a massive fleet is to maximize efficiency, optimize fuel consumption, and stretch out those replacement intervals to drive down your overall cost per hour, the Radial is the clear, undisputed winner. To wrap this explainer up, I want to leave you with this. Take a really hard look at your fleet's specific environment, your typical cycle routes, and your hazard levels. Are you truly matching the internal casing of your tires to the external realities of your job site? Or are you literally just burning through fuel and tread by running the wrong setup? The secret is on the inside, guys, so make sure you're choosing wisely. Thanks for hanging out with me on this deep dive.